Imagine you go back in time. Not a day, not a year, but decades into the past. You find your grandfather when he was young, before he ever got married. And then, you kill him. If that happens, he never gets married, your father is never born, and you never exist. But if you never existed, how could you possibly go back in time in the first place? So, who just pulled the trigger? Everything about this scenario becomes impossible because the logic collapses in on itself. And that contradiction has a name, the grandfather paradox. This paradox isn't just a simple logic puzzle. It's a problem with the very concept of time itself. So if time can break itself like this, why do movies make it look so simple?
I don't know why everyone believes that, but that isn't true. Think about it. If you travel to the past, that past becomes your future. And your former present becomes the past, which can't now be changed by your new future.
Exactly.
For decades, almost every time travel movie has relied on one simple assumption. Time is usually portrayed as a straight line. The past is behind you, the future is ahead, and every event unfolds along the same single track. Which means, if you go back to the past and change something, the future changes too. That's the logic used in many time travel films.
Are you seriously telling me that your plan to save the universe is based on Back to the Future?
Like in the movie Back to the Future. When Marty changes one small event in the past, the entire future shifts. It sounds reasonable at first, but there's one big problem. Because if the timeline is just one straight line, then the grandfather paradox completely destroys it. In a strictly linear model of time, you could actually prevent your own birth. And if you were never born, then the time travel itself becomes impossible. Which means this version of time travel can't survive logically. It violates the basic structure of cause and effect. Causes create effects, and for time travel to happen, you first have to exist. So maybe the problem isn't time travel itself, maybe it's the model we're using. But unlike many other films, Tony Stark and the Avengers don't use this linear model. In Avengers Endgame, they don't return to the same timeline, they travel into a different reality instead. But hold on, is time travel even possible in the first place?
Wait, are you talking about a time machine?
No, of course not. No, not a time machine. This is more like yeah, like a time machine. I know, it's crazy. It's crazy.
The answer might lie in this equation. Do you recognize this equation? Yeah, this is Einstein's general theory of relativity. Through this equation, Einstein showed that space and time are not separate. They form a single structure known as space-time. And more surprisingly, this equation reveals that space-time isn't rigid. It can become distorted and curved, and we experience that curvature as gravity. But Einstein's equation doesn't stop at gravity. When extreme conditions are plugged into it, the results become extreme as well. From there, the equation predicts things like black holes, wormholes, and something even more unsettling, a closed time-like curve. In simple terms, a closed time-like curve is a path where an object moves forward, yet eventually returns to its own past. Imagine walking straight across the Earth. You keep moving forward, and eventually, you arrive back where you started. A closed time-like curve works in a similar way, except you don't just return in space, you also return in time. This means that, mathematically, general relativity doesn't completely prohibit traveling to the past. It even opens the door to it. And that's where things become much more serious. Because if time travel is theoretically possible, then the grandfather paradox we discussed earlier is no longer just a thought experiment. It becomes a real problem that physics must answer.
Our time is personal to us. This is what Einstein had discovered. There's no such thing as absolute time. Time travel is possible.
Now at this point, we're left with two ideas that seem to contradict each other. On one side, Einstein opens the door to the possibility that traveling to the past is mathematically allowed. On the other side, the grandfather paradox limits that possibility. So how do we avoid this conflict? One way is to take the same approach the Avengers used, traveling to the past, but not within the same timeline. Instead, entering a different branch of reality. In other words, adopting the idea of a multiverse, what's known in physics as the many worlds interpretation. And the crazy part is that the multiverse concept isn't fiction. It's a legitimate interpretation of some of the strangest phenomena in quantum physics. To understand how this works, let's dive into the strange world of quantum physics.
Have either of you guys ever studied quantum physics? See, the rules of the quantum realm aren't like they are up here. Everything is unpredictable. Is that anybody's sandwich? I'm starving.
In the quantum world, reality doesn't behave the way we experience it in everyday life. And this is exactly what has sparked debate among physicists.
And here we are, the granddaddy of all quantum weirdness, the infamous double-slit experiment.
Take the double-slit experiment, for example. When particles are fired toward two narrow slits, they form a wave-like pattern on the screen behind them, suggesting that a single particle somehow passes through both slits at the same time. It's almost as if one particle can duplicate itself. This phenomenon is known as superposition.
The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle.
At the most fundamental level, a particle doesn't simply choose to be here or there. It exists in multiple possibilities at once.
But mathematically, it's even stranger. It goes through both slits, and it goes through neither. And it goes through just one, and it goes through just the other. All of these possibilities are in superposition with each other.
Which means, in the quantum world, reality is never truly singular.
Why can things in the quantum world hover in a state of uncertainty, seemingly being partly here and partly there? While you and I, who after all are made of atoms and particles, seem to always be stuck in a single, definite state. We are always either here or there.
From this understanding emerged an interpretation known as the many worlds interpretation. This idea was first proposed by a physicist named Hugh Everett. In 1957, in a paper, Relative State Formulation of Quantum Mechanics, Everett argued that if the laws of physics are followed exactly as written, then all possible outcomes should continue to exist. And that means the multiverse isn't a violation of physics, it's a consequence of what we actually observe in the quantum world.
Each and every possible outcome actually happens. Only most of them happen in other universes, parallel to our own.
And in the story, the Avengers are aware of this multiverse concept. So when they travel back in time, they don't return to their own original universe. They enter a different branch of reality instead. That's why, when they take the Infinity Stones, their world doesn't instantly change. No reality collapses, no paradox erases their existence. Their original timeline continues as if nothing has happened.
What if the fabric of reality was but a single thread of something much larger? What if your universe was just one of many, a multiverse? What if you could be in two places at once?
And if you look closely, Tony models his time machine using the shape of a Mobius strip.
Run one last sim before we pack it in for the night. This time in the shape of a Mobius strip. Invert it, please.
Processing.
Because in a structure like a Mobius strip, a path can travel along the surface, follow every curve, and eventually return to its starting point. And yeah, maybe this is the most scientifically grounded version of a time machine we can come up with, even if it still exists only in theory for now. But guys, we just discussed one paradox. We haven't even touched the stranger parts of quantum physics yet. We haven't talked about particles that can seemingly teleport through quantum tunneling. We haven't discussed entanglement, where two particles remain connected even when separated by impossible distances. We haven't even addressed why observation itself can change the outcome of an experiment. And all of that belongs to the same family of ideas we explored in this video, the sheer absurdity of the quantum world. So the multiverse or branching reality isn't some random fantasy. It's rooted in real theoretical interpretations of quantum physics. And even that is just one small doorway into a universe far stranger than we imagine. If this already feels mind-bending, trust me, we've barely scratched the surface. In the next video, we can dive even deeper into the quantum world and see just how strange reality can really get. And if you enjoy this kind of discussion, the kind that's half confusing but completely fascinating, you already know what to do, right? And maybe that's what makes physics feel both strange and beautiful. The more we try to understand it, the more we realize that reality may never have been as simple as we once thought. Just like the grandfather paradox, it doesn't destroy physics, it forces us to see that reality might be far more complex than we imagined. And if the universe truly branches, then the real question is no longer, can we change the past? But how many versions of us might already exist out there?